just kind of confused reality.
You know, if I can expand on that, because this is a fairly hot topic, and we were talking about before the panel. I view it pretty close to Maribeth, but we draw the line at trying to trick your brain. So we believe virtual reality is about fooling your brain into thinking that you're somewhere else. Whether you're on Mars, or playing the World of Warcraft, or you're on a beach. But you have a 360-degree immersion where your brain is interpreting the world around you as a totally immersive experience. Nothing grounding in where you are today. And AR for us is really about, exactly as the name implies, some type of information that's being inserted into your reality to augment your experience. And we had a fairly heated debate this afternoon about where you draw that line, whether Pokemon Go is AR or whether you have to have a HoloLens. We looked at the center and where we start to characterize mixed reality. And for us, mixed reality is anchoring those objects, I think as Maribeth was pointing out, into your world. So rather than just a tag hanging in front of your face, whether it's a near-eye display or a true transparent display, if I put up a dashboard in front of you with a schematic, you're not going to think that that schematic is part of the world around you. You actually realize that it's information. But if I have a green ring that goes around the valve, as Jim was pointing out, and is rendered relative to my position in the world and always stays exactly in that position around the valve, now I'm starting to trick my brain into thinking that there's actually a green ring around that valve. Because as I move, it doesn't float in my space, it's being rendered in my world. And I think that's a lot of the confusion that we're having as an industry, is people aren't realizing that mixed reality is incredibly hard. That's why Microsoft spent $1 billion to build a 2-pound headband to be able to do that. We're years away from that being built into a set of normal eyeglasses. But helping people understand that and the differences in our developer communities and our infrastructure to support those different things, and each of them have a place, I think is a challenge that we have. So the first step is getting clarity, and then the second step is, all right, what the hell do we do about it? And then third is hopefully how we make money. Yeah. Really, the IBM research guys put that?
This is what we've been waiting for. All right, well, thanks for that additional input. Rebuttal, or are we straight?
Yeah. I agree. No. But one additional thing I'll say is it's kind of important to think about these distinctions. I really liked your kind of characterizing like tricking the brain versus situating this information in the world, and the challenges of those two are different. Like the tricking the brain is hard because you got to make this whole virtual world, and you maybe need to show the person's representation of their body in this virtual world. AR is hard because we have to know where that valve is, and we have to figure out how to render that green ring to look right. And so, yeah, they can be different technical challenges and design challenges.
So just on that, and I think you hit when you were talking about your presentation, the ability to create the content is the biggest challenge here today. It's actually, I think it's easier to create content in a virtual reality world now, and it's because of all the gaming techniques and everything else, than it is in the augmented reality world. Because in the augmented reality world, you have to be able to anchor to something in the real world from whatever perspective the person's got, and that's a challenge. So while AR is probably simpler from a usability standpoint, it's definitely harder to make real.
It's really good. So, Chris, question to you. So Google kind of ushered in the mass awareness of augmented reality. If you kind of put Terminator to the side, real life augmented reality. As I think everybody here surveyed would say, probably wasn't the greatest success, but there were probably a lot of learnings from that happened from that. What makes today different? Right? Why is today's technology different, and what's going to make it applicable to the enterprise today?
I think there's two answers to that question. The first answer is I actually don't think it's different today. I think in many cases we're repeating the same mistake that Google made. And the mistake that Google made was thinking that it was a technology first, usability and design second. And there are many of us in that space that are making more attractive, more usable products and more, let's say, consumer friendly, or what I call more utilitarian products, because I don't think we really hit a consumer form factor yet that you would go wear that around town. Even our products. So I'll take the Recon Jet. I would never wear that out to a shopping mall or to dinner, even if I could get alerts on my face. I have no problem taking it out for a bike ride because it's designed for bikers. And when I've got a crazy helmet on and all my gear and my bike's all tricked out, nobody looks at me twice. But if I went out to dinner tonight and started walking down Peachtree with that thing, people would be stopping thinking, who let the RoboCop out? And I think as we're pushing that vector, and we start to look at pushing the boundaries of AR and moving into mixed reality, there's a lot of compute. The optics technology is still well behind what we really need from a density standpoint. And so as an industry, we're forced to build what I affectionately call science projects. My number one takeaway from Augmented World Expo, which was about a month or so ago in Santa Clara, was here's an industry body and a group of people that are specifically focused on augmented reality. This is the 6th year this conference has been going on. It's a couple hundred people, Maribeth, like 300, 400 presenters for 2 days on how augmented reality is here, the future is now, we should be going. Not one person got up on stage wearing their products. Not one person walked around the conference wearing their products. They're standing in the booth giving demos of their product, and they're telling you about the use cases for their product, but they're not eating their own dog food. Now, I'll couple that with, we're seeing a collision in the wearable space with fashion companies and with design companies. And what you're going to see are products that are designed first and technology second. And that's how we start to penetrate consumers, and that's how we avoid the glass hole problem. Because if you've ever bumped into anybody out in public actually wearing that, you get the same thought in your head that everybody else does, is yeah, you really do look ridiculous. So we're getting to it. And I think, the way I describe this is there's 2 vectors going on in our segment right now. A capability vector and a usability vector. And in the usability, we're thinking about the human factors of how people will actually use it, whether it's a workplace environment where I might be able to be a little bulkier, or it's a safety device and I can get away with a little more plastic, or in a consumer where I need to be able to blend in and identify with that person's image. But that's not going to stop the other vector, which is the capability vector of people pushing the envelope in terms of optical technology, in terms of positioning technology, and 3D sensing, and all the things that are moving toward where we all want to go. And eventually, like every segment, they all combine. So if you guys think about the first mobile phones, and we've all seen pictures of them, or some of us actually worked with them. They don't look like what's in our pockets today. But those were necessary but not sufficient to get to where we are. And I think we're looking at the same thing.
It's funny you said that, because that's exactly what I was thinking about. If you look at us today, not many people in this room carry bagphones around. And that was I had one, yeah. I don't know why, but I had one. But it's cool. But the same thing with all this, if it's a big, ugly device I've got to wear around here, it becomes impractical too, no matter what kind of safety it provides or anything else. And so we've got to think about what that visualization is. Is it a hologram, right? Is it some other kind of form? But I don't think we know what the form factor is yet. It's going to succeed, but I think the form factors that we know today, none of them are going to be massively successful because they're just.
Let's counter that statement with, Andrew makes a great point. The products we have available today, in certain verticals and in certain instances, actually improve your efficiency, they improve safety, they actually are today. So, in limited cases, in very specific use types, we are here today. And we can deploy and we can implement, both in consumer and in enterprise. But as a broad industry where we think about millions and we think about, you don't remember a time when people didn't have that, we're a little ways off.
Actually, Chris, if I could ask you a quick question on the differences. So do you think expectations are different today? So like when glass first came out, how many of you guys saw that video that was like, oh, you get to magically see the world in front of you, augmented with like the clock, the time, someone's space, right? Like, but now we think of glass and we're like, oh, well, that's, it's not exactly what happened. But today when people think of augmented reality, they think, oh, I must see a small display on the lower right corner, and that's exactly what I'm going to get. And so expectations match reality. Do you think that plays a role? in where we are today?
I think it depends on who you ask. And actually, I'm sure the glass video was the first one you saw. I'm going to give a shout out to Jim's company. The first video I ever saw was a commercial about compute technology, and it was a guy standing in a public square, and he had a transparent display in front of his face, and they were showing compute, near-eye display. And I think this is probably, I'm going to date myself, but maybe like 10 or 15 years ago? Yeah, at least, right? Okay, probably longer.
Time goes fast.
It does, right? Yeah, dog years in tech. But I think the reality, it depends on who you're asking. And I think the challenge we have as an industry is getting these things out of the R&D labs and into the operational side of these businesses. And no offense to anybody in the room who works in R&D, because God love you, you're the what drive our industry and keep pushing the envelope.
Yeah, I started in R&D.
Yeah, but people that are in R&D that are paid to look at the next great thing are never satisfied. That's why they're doing the job that they're doing. And so we might get to a solution that could work, but guess what? Some guy just called me, or I just saw on the internet, or there was a conference last week, and I just saw this new thing that I gotta go check out. And so I'm gonna go spend the next 6 months studying that, instead of saying, okay, I think I'm done, I can go home, right? This is job security for these people, and this is what we pay them to do. What we have to do is we have to find those formulas, we have to build the ecosystems that cross into the operational side of this business. And the interesting dynamic is, by doing that, we'll actually accelerate the R&D, because the bigger the business gets, the more money that goes into it, the more innovation that happens, keeps those R&D people even more employed. But if you keep it in the labs, as we can testify for how long some of us, and some of our colleagues have been in this space, you keep it in the lab, that's where it's going to stay.
So I think that plays nicely into our next question. So you look at, and I've been around the country, I've been around this room here looking at all the different demonstrations, right? And you look at what is required to make these efforts functional. And it's a lot of heavy lifting and a lot of work. And so, question to you, Andrew. What's that?
I'm ready, let's go.
Ready? How do you go from those R&D efforts to scalable solutions that the enterprises want to take on?
That's a really good question. So I'm the Director of Partnerships now, but I actually started in R&D and sort of transitioned over to this role. To answer this question, I think it would be nice if we go on a customer journey. So imagine you're a customer, right? And you have this R&D lab, you have your pilots, right? Well, I think there are 4 stages. You start with the proof of concept, right? You go over to this conference, you see this amazing new technology, you say, you know what, I want to see what it looks like. And so you bring the guys back, you bring the company, you start the conversation, you say, oh, what are the use cases? It's about drilling down that use case. And so what we do is we take our experience from the past 5 years and we say, okay, you know what, this use case will work, this will not, this will work. And we whittle it down to that one use case that has the highest return, is the highest probability of working, and that's where we start. And then the second stage is that proof of value. So that's where we create this pilot, right? And so we create a very, very cheap pilot, because a lot of companies don't want to spend $500,000 on their experiment, on their science projects, right? And so what we'll do is give them a very cheap option to say, you know what, we just need to prove that this works for this use case. And that's the proof of value step. And once we can prove that ROI, that's when we can get into the deployment. And that's the third step. And for the deployment, it's all about taking what we learned from the pilot and expanding it outward. And that's when we bring in things like the IT department. That's when you bring in things like the bureaucracy, right? But that is how you make it to a bigger product. And once you make that deployment, you can deploy that across different business cases. So I'm going to do a plug for Skylight, actually. With Skylight, it doesn't support just one use case. It can actually support multiple use cases, right? And so at one company, there's going to be hundreds of different use cases. And once you integrate with their IT system, you can go wherever you want. Because they're like, oh, you want? It's already work that we did. We might as well just stick it somewhere else. And so those 4 steps, it's the proof of concept, proof of value, and the deployment, and then expansion. Those are the 4 steps in this customer journey. And of course, using a company or partnering with a company like Accenture, Deloitte of the world is also really helpful, because they already know the backend, right? And so you can go in, they already know how to integrate it, and that makes the process a lot more smooth.
I was going to add one more thing about, you do these pilots, you do some evaluation, and you're like, okay, well, this is going to, improve safety by this amount or productivity by this amount. And then you deploy it in the real world, and this kind of connects to what Chris was saying, is that sometimes with these like wearable sort of systems, where you're asking people to put things on their body for hours at a time, and they're going to maybe repurpose that technology in different ways. And so sometimes you may be surprised about what happens when you really deploy it. I was at a safety equipment conference, and there was a speaker that was discussing a sensor that they had created for miners that would test air quality. And so the idea was, this is going to give them an early alert, canary in the coal mine type warning, if they're in an area with unsafe air in it. Wonderful. They did all, they studied, they were able to show that the performance of the device was good and that it would fit on the vest and everything. So then they deploy it. And they just kind of assume, like, well, this must be going great. Well, it just so happened that the sensor had an accelerometer on it. And so they started looking at the accelerometer data, and they realized that the sensors were never moving because the miners would get down in the mine and take it off and leave it at the. So, so it didn't matter that this thing would work great. For whatever reason, the workers did not want to wear it. So we have to consider all these aspects of. When we say fashion, sometimes people are dismissive, like, that's for preteen girls or something, but. It's about wearability and social wearability. Like, why did those guys not want to wear it? Maybe because they felt they were being monitored by their boss and, they're getting in trouble or like, who knows? But you have to explore all the elements of the context, of the deployment as well.
So, you had a really good point with that too, because when we're in the prototype phase, it's okay to strap something around somebody's arm or put something big on their head, right? But when you move into the real world environment, it can't be intrusive to it, because they will find ways to lay it on the floor, whatever. So we're working with a couple of companies around embedding sensors into clothing, for example. So working with the athletes so that we can gather data from the athletes with embedded sensors in the clothing. The clothing looks just like any other clothing you get, right? But we're able to gather data from that clothing. And so you think about the implications of that. You've got a walking set of sensors. You're not intrusive at all to the athlete in anything they're doing. And same thing with worker safety, right? If I have a worker safety device that the person has to wear that's intrusive in any way at all, it won't be, right? But if I can show value from it, if I can show something that makes that worker realize why it's important to wear it, then it will. And so we've got to realize that as a geek, right, it's really neat to be able to build these things and throw them on people, but in the real world, they're not going to carry that bag front around, right? When it gets to be a small device they can stick in their pocket, it'll be real.
Just a quick response to that. That's a really good point, right? And so I think the takeaway is that the pilot has to be as close as you can get to the deployment, right? Minimal effort, but in terms of the form factor, in terms of how it feels to the end user, it should feel like a deployment. Just don't spend as much money.
I think there's one last element that we tend to ignore, especially in the enterprise space, and especially as we're moving in, not just to AR or head-worn displays, but all wearable technology, is that these are real workers who are very protective of the data of what they're doing on a day-to-day basis. And in many cases, like in mining, you're dealing with a labor union. I won't name the company, but I'll just tell you that in talking to a company that does field service, they shared with me that their union rules were that a certain service repair takes 2 hours and has for the last 10 plus years. It's a total agreement between management and the labor union that if you assign that task, that worker has 2 hours to complete it. In working in head-worn displays and efficiency and trying to write a training video, they found out it takes 40 minutes. Getting the labor union to agree that repair takes 40 minutes when they've had a decade-long contract that says it takes 2 hours is a massive barrier to deployment. No matter how many KPIs you prove out, no matter how much efficiency management will rule out. So there's many, many, many human factors we have to think about now that go well beyond just, I can reach you at home on a mobile phone so everybody in the company is getting one. If they actually started looking at the GPS data and started to know where you were and what time you showed up by your phone and what time you went home, we'd all be throwing them in a pile inside the office door when we walked in. So these are real factors that as an industry we're thinking about, but we have to continue to think about how to do this in a way that protects people's privacies, that doesn't violate trust that we have in the organizations that we're trying to help.
So, thanks for that additional insight. One follow-up question to you, Andrew. So you guys are a startup. You have limited resources, right? You have to know, what are the real opportunities? What are the indicators for you as you go into an opportunity? How do you determine whether it's just somebody who wants to learn more about the space and is interested in doing some fun stuff with their business, and those that are really trying to solve business problems?
So one of the very first things is, actually, this is a great question because over the past 3 years, actually, we've gone from the state of, if someone knocks on the door, we used to always say yes. We'd be like, oh, we can totally do that, no problem. And they're asking for outrageous things, but we're a startup, or we're a startup at that point, definitely. And so now it's more at the point like we look at the company, and this is to answer your question, we take a look at scalability, right? So one, can they take this product and can they deploy it into a scalable deployment and make it actually affect their company? Second is, can they, in their use case, get a true ROI? Or is it just going to be something that helps shave just a couple seconds off, right? And so we want something that can show true ROI, show great returns, error reduction. And the third thing is just the ability to see, actually I don't really know how to phrase it, so I'm just gonna stick with those two. But it's just the idea that when you look at a company, and if you take a look at how they're going to be using this device, are their workers actually going to benefit from it? That's the first question, right? And the second question is, are they going to keep on using it and use it in a scalable deployment?
Are there some indicators of willingness to invest in the beginning of the process?
Absolutely. In fact, you know what? I'll call that my third thing.
So, Jim, we talked a lot about AR, VR as it relates to smart eyewear and what's on your head and that kind of interaction. Can you shed some light on kind of how maybe AR or VR should be considered more broadly?
Well, I mean, I showed some of the examples there with some of the other device types for interactions. But I mean, we're at a point really where there is no limit on the types of things that we get. I mean, I've seen the auto mechanic approach where they have an eye display and it visually shows them what the parts are on the car. I've seen worker safety type things where they, we're able to point out, don't touch here, right? And be able to say, or be able to do things like take this cover off first, this off second, watch this screw, it tends to strip out when you try to do it. Those kinds of things there. Seen, around athletes and helping athletes understand, how they're performing. One of the groups working with is around some of the Olympic teams, and using AR to augment so that they can see what their performance is in real time. So, take an example like a rowing team, right? Is everybody rowing exactly in sync? Right? And think about the ability to get that kind of data in real time as an augmented type of a flow, so that you can see. And not only to the athletes themselves, but also the coaches, so the coaches know what's going on in real time. So to kind of go back to where I opened with, it's the combination of the ability to collect this data now from any source that's out there. Sensors have come down to, buy them in volume on Amazon for pennies now. You've got cloud services from Amazon, from Microsoft, from IBM, where you can go out and build applications in literally minutes for a lot of these things now to be able to prototype them. And then you've got all this flexibility around communications. Everything can be connected now worldwide. It's really, if you're willing to pay, you can get it for satellite. But when I look at just the availability of connectivity for data, and we're instrumenting sensors in sub-Saharan Africa to be able to measure water. Think about being able to bring all this kind of data in, the type of implication it has. So there really is, it's kind of a cool time to have no bounds around the possibilities right now.
I think the other element that we tend not to talk about is the man-machine interface into these systems. So we talk a lot about the display, we talk about see-through versus near eye, and VR, and is it occluded or not occluded, but the man-machine interfaces are evolving as well, and none of those are perfect, and none of those are one-size-fits-all. So we're building an audio platform for Oakley that'll be out later this year that's a coaching platform that'll give you a very natural interaction. And it works great, except if you get on a bike and try to ride 45 or 50 miles an hour as a high-performance athlete, it's really tough to speak to your glasses with wind whipping past you. Take that and put it into a manufacturing environment. Voice interaction is fantastic, except if I've got machines going around me. So what's the answer? You go to gesture. Well, gesture's great, except I'm working with my hands, and the whole thing is I'm supposed to be doing a job, so my hands are supposed to be down here on a tool, not up here in front of my face. So maybe it's just touch. Well, if I go into healthcare, I can't touch the glasses, because if I touch the glasses in a sterile environment, I've got to leave and go re-scrub in. That's right, exactly. And it will continue to evolve. I mean, if you even look at VR, where we've all assumed it's just a gaming console and you've got a controller, but if you've tried Tilt Brush, where you can actually paint and create physical objects, pseudo-virtual physical objects in your pseudo-virtual world, it's an amazing tool that completely changes the dynamic of how you interact with that environment. So I really think those interfaces, and Maribeth, I know you guys are doing a bunch of work in that space.
Yeah, and sometimes I use the term contextually accessible, and so I do a lot of work with wearables for people with disabilities. And in fact, if you're solving a problem for like a blind user or a deaf user, you're actually inventing a great interface for someone in a factory or a soldier in the dark. And I think maybe the answer is that these systems need to be able to adapt their interface, not just on the physical environment, like light and sound. It needs to be based on the task you're doing and the physical demands it has on you, like you're pedaling hard or you're having to use both hands, or the cognitive load. That's the danger even with some of our mobile applications, is that you can't drive and attend, not just with your eyes, but attend cognitively to the system. And then, again, there's this issue of the social environment that you're in. And is it appropriate for me to be doing this or to be speaking commands? Or the example that I love to give, there's an old wearable interface that a company designed. They needed a touchpad that on the body that you could access pretty easily to control a wearable product. And so the obvious place was the belt buckle. And I mean, the belt buckle's right there. You can, but if you're walking around rubbing your belt buckle, somebody's going to call the police, right? Yeah, so I like the direction we're going with this discussion, because I think when we talk about AR and VR, we think about display. We think about visual display, and we don't think about how am I interacting with all this content. And sometimes the idea it's just going to be natural. I'm going to just be pointing and grabbing. And anyone that's never really used those systems, you realize how fatiguing they become and how silly you feel using them.
So one of the things that's happened too is the workforce. If you go and talk to anybody in pretty much any industry you go to, one of the first things they say is, my workforce is aging and my skills are retiring. And I always had retired or dying. But the problem we've got is the younger worker doesn't have the ability to walk in and look at that and say, it's broken. Right? They don't have the ability to walk in. I remember going in with a guy, and he was so proud. He says, I go in with my screwdriver, and I just put my screwdriver down on this, and I listen to the vibration of the screwdriver, and I can tell you if this is going to fail or not. And he was dead right. He can tell you that. You take a young kid, and you go, which end of the screwdriver do I use? Right? And so these skills are being lost, and the ability to do this diagnosis is being lost. So part of this transition is AR can be a tool for us to use to transition this domain knowledge, right? So whether it's instrumenting the pump so that I can see, here are the 5 steps you do to do things that old guy knew that the young guy doesn't. And it's not just a repair or a time kind of thing, it's a safety thing as well. And making sure that you don't have more downtime or repair issues or problems with the work or whatever. So the aging workforce is, I think, going to help drive some of this as well.
Really insightful. So I think we've got about 10 more minutes. I want to reserve that for questions from the audience. So any questions from the audience? So in AR environments, we're going to deal with a new set of ergonomics with stuff that's just not there.
That already exists. When you talk about haptic feedback, you're talking about these devices, and you're talking about ergonomics that were exactly what you said, or these things that don't exist. So, I mean, I would say that that is already here. From our side, I mean, talking about when you look at this wearable display, you think, you know what, I can take a phone app and just stick it on there. Turns out that is definitely not the case. That was probably the number one thing that we learned very quickly.
So what kind of standard language, are you seeing standard languages today emerge for this space?
So I'm gonna interpret your question more broadly than just a programming language, and I'm gonna interpret it to be more of a translation. I think today, when I think about where most of the space is coming from, it's coming from the gaming world, and so you're really talking about coming from gaming engines, right? A Unity engine, an Unreal engine, something like that. If you look on the AR space, traditionally today, because of the capabilities of the systems, where we're at is text-based systems. We're at systems that are converting knowledge bases that are typically decades of 8.5 by 11 PDF documents and converting those to things you can consume in small displays. That's one of our biggest challenges. As we start to look forward into mixed reality, I think what you're going to have is a hybridization of that. So you're going to have technical writers and people writing specifications that are actually going to have to be able to program holograms or hologram-ish things, to Maribeth. You're going to have to program graphical content through game engines or tools similar to that, instead of just having a 2D diagram and a couple of paragraphs about what that schematic does. So I think that will be the evolution, and you've seen it. If you have any interaction with the game engine vendors, with Unity or Unreal or any of these others, they've been moving into that space quite rapidly, and I think the open sourcing of those engines is accelerating that.
Yeah, I think that, this is actually true with any computer interface. I mean, if I sit down to make a desktop computer application, theoretically, I could have any interface I wanted, right? But we have kind of a standard set of user interface widgets, and the advantage of that is that you can assume maybe that your user is going to understand what those are, and the programming tools kind of have that stuff built in. So it's like, let me have a slider here and a text box here. And so although when we're talking about like VR interfaces, there's all kinds of crazy things that people have been inventing for 30 years in VR, but we probably will see, in order to make tools that are kind of more approachable to developers, to be able to interfaces that a new user is able to just adopt, we're probably going to see this kind of naturally develop. And I agree, I think we can learn a lot from gaming interfaces, because there's millions and millions of people that are already used to them, and there's been lots of money and thought put into how do I have a 3D scene but I can represent, information. And so there's a lot to learn by looking at game interfaces.
I was just say that when you look at how you want to create this content, though, if you think about how many people would have thought 10 years ago that I'll have a device that I touch the screen and I slide things around on, right? I've got to have a little mouse or something here. But think about how everybody, I've got a 2-year-old grandson that can navigate an iPhone better than his mom can, right? And it's because it became intuitive to be able to use. And I think the same thing is going to be true here. The current form factors and interfaces and everything that they are what I call release.1, right? They're not the iPhone yet, right? And it's when they become the iPhone or the Droid or whatever else, that's when we're going to start seeing widespread adoption.
So 3 AR examples that are consumer friendly.
And I'm going to go way out on them, the rest of the panel probably say I'm crazy, but have you watched an NFL football game in the last several years? The yellow line is augmented reality.
That's right.
If you watch a baseball game, there's a green box behind the batter if you're in the ball field. It's an advertisement. It's changed. That's augmented reality. So we've been doing augmented reality for quite a while if you take the very basic, where we're augmenting reality with additional information. So, start with all of that. That's been around for a long time now, but that's an example of a consumer-facing thing that we can't live without that yellow line on the football field now. Sorry.
The other one I would point you to is Blipper. If you haven't seen their capabilities, they've been integrating with media companies and integrating content into ads and into your real-world environment that does come up on your phone. It's probably not nearly as prolific as Pokemon Go, but it's another capability that's been out there, and there are numbers, but I think those are two real-world examples for sure.
What are the components of an AR/VR experience that need to come together for the experience to be real?
I want to answer that because that's what my dissertation was on. So settle in, no. But yeah, so actually, more than 10 years ago, I and my colleague at Georgia Tech, Blair McIntyre, made an AR authoring tool that was inside of Macromedia Director, if anybody remembers that. But the thing about Director and Shockwave was it was like a really accessible way for people to make like interactive, like web applications. And so we wanted to start with a tool like that that was usable by people that weren't like, extreme computer science sort of technologists. And I'll say that what I've learned, because what I wrote about in my dissertation was like, what are kind of the key aspects of AR authoring that's maybe different than writing a regular application? And there were a couple of interesting findings. One was that you need to be able to prototype easily and like brainstorm. And we have a lot of ways of brainstorming like a website. We can make wireframes or Sketch or whatever. Well, how do I do that equivalent for like an AR application that's supposed to be inside of a historic site or a factory or something? And so inside of our tool, we had ways where you could take things like sketches and kind of evolve them into augmentations and experience them in the space. Another aspect was debugging, because AR is really hard to make working AR applications. You're tracking the person, you're maybe getting a 3D model of the environment, you're trying to place all this content in the world. So having facilities that helped non-experts be able to figure out like, why am I not seeing anything? I put this head mount on and there's nothing. And maybe there's nothing because their model is actually like 10,000 miles big in their engine. So they're like inside of the Pokemon and they don't even know it. But anyway, so long story short, the only one aspect is like the programming language and like how do I import some content. But there's all these other aspects of ideating, prototyping, debugging, deploying, evaluating that I think a tool needs to have. And I think it's not one tool, it's integrating into tools people are already using. So if you're in an industry where it's like, well, we use this sort of CAD program, or, we create technical manuals using these tools, can we add AR stuff to that existing tool like we did with Director?
It's getting close to the dissertation.
Yes.
So, one more question, I think, sir.
Yes.
So first off, I'd like to assume that it's not satellite, but perhaps cellular. I had a company in mind, we can talk about that if you'd like. What do you look at, so to the panel, what's the communication path for this content? So to the panel, what's the communication path for this content?
I mean, the reality of it is, you're going to have to do some kind of pre-staging for a lot of this type of stuff. Right? Or you're going to go really big cellular bit. But I think from a responsiveness perspective, there's no way that you're going to be video streaming up and hooking anchor points in real time with where we are with technology today. But I do think if you, to overuse the term augmented, but if you augment the data stream in different ways, right, so that you understand hook points in it and, leverage things around the device, so it becomes kind of a mixed mode application of there's stuff coming from the mothership, but there's a lot of stuff happening on the device itself, some of it preloaded or pre-learned. I think it's going to have to be that way for a while. But as with everything, the technologies are evolving so fast and network speeds are evolving so fast that, things that we don't think are possible today will be possible a year from now.
We're out of time for questions, but I'd like to give this panel a hand.